Hello and welcome to a short lesson on factorizing algebraic expressions. What is factorizing? Let's have a look at everyday numbers to see what exactly factorizing means. If I write the number 6, I can write it as 2 times 3, where 2 and 3 are factors of 6, numbers that divide into 6. So that is expressing 6 as a product of its factors multiplied together. Another example would be 15, which can be written as 3 times 5. So I've factorized 15 into 3 times 5. One last example, 20 is 2 times 10. So 20 has been factorized into 2 times 10. It hasn't been what we call completely factorized because I can write that as 2 times, and instead of writing 10, I can write 2 times 5. And that's what we call a complete factorization of 20. Now let's move on to algebraic terms. Factorizing is the opposite operation to expanding brackets, and you should now have looked at the lesson on expanding brackets. So let's suppose we have something like 3 multiplied by x plus 2. We've seen how to expand this. What we do is we multiply the 3 by everything in the bracket. So 3 times x is 3x, and 3 times plus 2 is plus 6. That's called expanding the bracket. Now factorizing, we need to go back the other way. So what we do is we look at this expression here, and we look to see if there's something in common in both terms. Well, there's only an x there, but not at the back, so x isn't common. But what about the 3 and the 6? What divides into both 3 and 6? Well, of course, it's 3. So what we do is we pull the 3 to the front, and then we rebuild the expression in a bracket. So what do I need to multiply 3 by to get 3x? Answer, x. 3 times x is 3x. Plus, because the signs are never going to change, we're only pulling out positive factors here, so any signs in the bracket will stay the same. But what do I multiply 3 by to get plus 6? Answer, plus 2. And now you'll see we've arrived back at that expression there that we started with before we expanded the bracket. Let's have a look at another example. If I had p multiplied by the bracket q minus r, and we expand that bracket, we get p times q is pq, and p times minus r is minus pr. Right, now let's go back and factorize pq minus pr. What is common to both those terms? Answer, p. So we pull the p to the front, and then we rebuild the expression. I ask myself, what do I need to multiply p by to get pq? Q. Minus, what do I multiply p by to get minus pr? It's minus r. And you can see that that expression there is the same as we started with here. So that's called expanding the brackets, and then if we factorize, we're back to having the bracket. Right, what we're going to do now is work through 12 examples that will gradually get more complicated, but they'll show you the typical exam questions and perhaps some that are a little bit more difficult than exam questions. And then you'll have a chance to do an exercise of 20 on your own. Right, number 1. What is common to 4 and to plus 6t? Well, there's no letter common, but numbers wise I can see that 2 goes into 4 and 6. So I can pull the 2 to the front, and then I'm going to rebuild the expression. What do I need to multiply 2 by to get 4? Answer, 2. 2 2s are 4. Plus, what do I multiply 2 by to get 6t? Well, I need to multiply the 2 by 3 to get it up to 6, and I also need to multiply by t to get the t involved. So when we factorize 4 plus 6t, it's 2 bracket 2 plus 3t. Example 2. The y certainly isn't common, but the 3 is, so I can pull the 3 to the front. Rebuild the expression. It's all about rebuilding expressions, factorising. What do I multiply 3 by to get 3? Answer, 1. 3 ones are 3. Plus, what do I multiply 3 by to get 3y? Well, I don't need to multiply by a number because the 3 is already there. But I will need to multiply by y to get 3y. 3 times y is plus 3y. Example 3. 8 and 6. Common factor, 2 I can pull to the front. Can't get a p because there are no p's over here. Let's rebuild the expression. What do I multiply 2 by to get 8p? I need to multiply by 4 to get 2 4s up to 8. And I also need the p. 2 times 4p is 8p. Minus, what do I multiply 2 by to get up to 6? 3. 2 3s are 6. 2 times minus 3 is minus 6. Example 4. 10 and 15. Well, I can pull 5 as a common factor here. I can't get the p because there's no p at the back. I can't get the q because there's no q at the front. So 5 is the only common factor. Rebuild the expression. What do I multiply 5 by to get 10p? 5 times 2 is 10, and I need to multiply by the p to get the p involved. 5 lots of 2p is 10p. Plus, what do we multiply 5 by to get 15q? 5 3's make 15, and I also need the q in there. So 5 lots of 3q would be 15q. Example 5. 6xy plus 3x. Let's look at the numbers first. Have we got a common factor in the numbers? Yes, 3 goes into 6 and 3, so we can pull the 3 to the front. But this is our first example where we can pull something else to the front as well. We've got an x in here and an x in there, so the x is a common factor. We can pull it to the front. Rebuild the expression. What do I multiply 3x by to get 6xy? I need to multiply the 3 by 2, and I need to multiply by y. And then I'll have 3 2's are 6, and x times y gives me 6xy. Now what do I need to multiply 3x by to get 3x? I've got to put something there. If I don't put anything, the 3x won't appear. I multiply by 1. 3x times 1 is 3x. Anything times 1 is just itself. Example 6. X squared minus 5x. X is involved in both terms, so I can pull x to the front. I can't pull x squared because there's no x squared here. Right, let's rebuild the expression. What do I multiply x by to get x squared? Answer, x. X times x is x squared. Minus, what do I multiply x by to get 5x? 5. X times minus 5 gives us minus 5x. Okay, we'll move on now to look at 6 more examples. You can see these look a bit more complicated. First of all, this one here, y squared plus yp. Common factor is y. Pull the y to the front. Set about rebuilding the expression. What do I multiply y by to get y squared? Answer, y. Y times y is y squared. Plus, what do I multiply y by to get yp? P. Y times p is yp. Example 8 has 3 terms, but factorising is just the same. We need things that are common to all 3 terms. Well, I've got a p and a q, p and a p, p and an r. So the only thing that's common to all 3 of them is the p. Let's rebuild the expression. What do I multiply p by to get pq? Q. Plus, what do I multiply p by to get p squared? P. P times p is p squared. Plus, what do I multiply p by to get PR? r. So the factorization is p times q plus p plus r. Example 9. X cubed minus 2x squared. Well, I can get x to the front, but I can do better than that. I can get x squared to the front, because x squared is contained in x cubed and x squared is contained in x squared. Rebuild the expression. What do I need to multiply x squared by to get x cubed? Answer, x. If we multiply x squared by another x, we're up to x cubed. Minus, what do I multiply x squared by to get 2x squared? 2. X squared times minus 2 is minus 2x squared. Example 10. PQR plus QRT. What's common to both? Well, the P isn't, because it's not in the second one. But Q and R are both there in the first term and the second term. T isn't, it's just in the last one. So I can pull both Q and R to the front and then rebuild the expression. What do I need to multiply QR by to get PQR? Answer, P. Plus, what do I multiply QR by to get QRT? T. And that's the complete factorization. Both the common factors have come to the front, and I've rebuilt it with the bracket P plus T. Common factor of 15 and 10. I can pull 5 to the front. What about H? I've got H in both of them, so I can pull H to the front. What about K? I've got K squared, I've got K, so I can pull K to the front. Can't pull K squared because there's no K squared at the back. Rebuild. What do I multiply 5HK by to get 15HK squared? Now just build this up slowly. What do I multiply 5 by to get 15? 3. 5 3s are 15. H is already there. I don't need any more H's. But I need a K squared. So that K needs to be multiplied by another K. K times K will give me the K squared. Minus 5HK, I need to get minus 10HK. The 5 needs to be multiplied by 2, but the H is already there and the K is already there. So it just stays as minus 2. 5HK times minus 2 would give me the minus 10HK. And the last example. TP squared plus PT squared. Well, I've got a T in both of them and I've got a P in both of them. So I can pull TP to the front. Rebuild the expression. What do I multiply TP by to get TP squared? Well, T's already there, but I need to multiply by another P to get the P up to P squared. Plus, what do I multiply TP by to get PT squared? Well, the P's already there, but the T needs multiplying by another T to get it up to T squared. Final answer, TP multiplied by P plus T. Right, you've seen a good assortment of examples there on factorising. That concludes the lesson. Have a go at the exercise.